Everyone is looking at the government and the big ticket items. So we're doing lots more on generation. You've seen all the news that we're going to be building more wind farms. We're going to go for nuclear. There'll be more development of the grid. But something that the Committee on Climate Change and frankly the whole industry has been looking at and saying perhaps there's not been enough movement is energy efficiency. It's not as sexy, all right? It's not as sexy as building something big, but actually, could it be one of the most important tools we have to get to net zero? By saving energy that we don't have to use, could that be the way that we can move the dial forward? Now, you've heard of building management systems, perhaps, but have you ever heard of a system where there's a plug point that's smart enough to know if it's on or off? Well, that is one of the things that will probably be a real breakthrough in trying to get us more energy efficient. And I'm delighted to say the man who came up with this crazy idea, actually, I say it's a genius idea, is Dan Williams from Measurable Energy, and he joins me for this podcast. Dan, hello.
Hello, good to be here. Nice to see you.
Nice to see you. Now, look, I said just earlier about the big ticket stuff. Before we talk about what Measurable does and this incredible, very impressive plug point thing you've built, where do you see this? Because it is quite obvious whether it was, Boris before or whoever's been in power, something about, hey, everyone, we're going to build a nuclear power station, a massive wind farm. We're going to build a gas turbine in the old days. That's where we kind of look, we're going to redo the grid. There'll be lots of new cables. We seem to be obsessed with the way to solve this is more generation and infrastructure. Do you think that's kind of been the case?
I think the answer is multifaceted, right? That is part of the answer. Perhaps some people would say those sorts of things grab attention more for
Yeah.
people, and they do. That's kind of cool and interesting, and you can really understand that it's new and exciting. And I think that is definitely part of the solution. But yeah, the non-interesting, sort of more boring side of it is energy efficiency. It always has been. Energy efficiency obviously has been around for a long time. It's not really something
But
that
it's
is
something we can all do, isn't it? That's the thing. You can't build a wind turbine unless you're an engineer. We can all do this.
we can. And in fact everyone does it, right? You turn off your tap, for example. This is the best example of energy efficiency. If you had a dripping tap, you'd think that's not right. This is not an efficient tap. So I turn it off and it's dripping. So yeah, it's something we all do.
It's the classic thing. My dad, who's long gone now, but he used to torment me in my teenage years. Turn that light off. All right, don't use the phone too much. And now I find myself doing the same thing, which is quite hilarious. But I mean, apart from the jokes about it, businesses have been looking into this for quite a while, right? They've been looking at things like LED lighting, and they've been looking at kind of, sensors and things like that. And some people have put in lots of great things. Why did you think there was scope to still explore this more?
Yeah. Again, there's been a big focus on heating, air conditioning, and lighting. Those are the sort of classic, especially for
Yeah,
commercial buildings, which is what we focus on right now. Those are the classic building management systems that have had loads of innovation over the past 20, 30 years. And they are really now, they can be very efficient if used properly. But there's always been a sort of trifactor of energy usage within a building. So HVAC, lighting, and other you can sort of classify as plug load. Anything you plug or wire in, and it's always been one that there is no building management system. I talk to a lot of people, that we hang out with, and they've always seen it as just an unregulated, uncontrollable energy load that used to be small, right? Especially compared to lighting of the old days.
yeah, of course.
It was small, but with new devices that everyone's plugging in, loads of monitors, loads of coffee machines, loads of like nice stuff that's all over your office that's plugged in. That has kind of relatively increased, but also actually increased as well to become sort of 40-ish% of a modern office. So it's
Wow,
quite
wow.
significant. Yeah,
That's
yeah.
really so. The amount of plug points you have and the amount that they're drawing can be up to 40% of your energy spend.
It can be, yeah, yeah, yeah. In fact, it's been a little bit higher in some places we've gone to. Obviously, it depends what you do in a building, right? If you've got nothing going on in the building in
Yeah.
terms of desks, then it's going to be smaller. But if it's a normal office, 40% is not an unusual number.
What is your background before we talk about what you've sort of come up with? Are you an engineer? What's your kind of interest in energy efficiency and how it became, the seed of forming measurable energy?
Yeah, I mean, it's always been something I've focused on, this area of sort of climate technology.
Right.
It's always been an academic start for me. So I actually did an engineering doctorate. Not that I'm if I said I was an engineer to an actual engineer, they'd not talk to me again, I think. Um,
You're a
I
good paper
didn't.
engineer, is that right?
Kind of, yeah. I hide that quite often from people, but I started my sort of academic career off with a commercial entity, so I did this engineering doctorate. So basically a
Right.
PhD within industry. So I did that for 4 years with Microsoft and their global sustainability team, trying a lowly sort of PhD student trying to answer the question, what is the environmental impact of Microsoft's technology?
Right. Yeah.
It's a huge question, right? So through that process, I got access to Microsoft's data and all of their locations, and actually was able to work out how you would measure this, how you would manage it. And that was really where it all started because that uncovered so many sort of quite obvious techniques and strategies to reduce wasted energy, especially, the the thing I often found in that sort of case in a tech company was if you just turn something off, it makes quite a big difference. And it sounds incredibly obvious, and actually it is. But if you do that across a building of 10,000 people, it then does become a sort of management challenge. Well, who turns it off? And is it right to turn it off? Are you sure you should turn it off? There's all these questions that sort of form. And that was the sort of beginning of my sort of career in this. I actually started a small consultancy up that then worked with BBC and Google's sustainability team too, doing the same sort of analysis work, and it was all theoretical. It was all really interesting and
Right. Yeah,
brilliant
yeah.
outputs. But yeah, there was always this kind of, well, let's just take an action forwards from all of this great theoretical work, and that's sort of where Measurable began from.
So I know you guys this is like classic, if you're I don't know if it's still going, Blue Peter, but anyway, here's one I made earlier. Right, so you've got this plug board that you've made. Can you show us it so we can see what it looks like?
Yeah, I can. It's the most underwhelming demo on earth, unfortunately. But
It looks
this,
like a plug point.
well, that's because it is. That's what it is. But it's very different inside, right? So it's very thin. It's actually thinner than a sort of normal one you can get. I should show you this as well. This is our new one. So we make lots of different types
Yeah,
of sockets, right? But yeah, inside there is the smarts, really. It's a smart power socket. You can buy one of those for your house if you want. It's the same
yeah.
sort of thing. But the difference with this one is that we've embedded a bit of machine learning inside, or AI, if you want to term it, in a marketing way. It's the smarts that makes everything different for us.
So what does it do? So I plug in. All right, I've got right now in front of my desk. I've got a phone, I've got a lamp, and I've got my computer. Right. So your smart plug, I'll plug it in. Is it smart enough to know what those things are?
It is, yeah. So that's the fundamental thing of what we do is
Wow.
work out what's plugged in. Yeah, yeah.
So it can tell. How have you taught it to know a phone plug from a lamp plug or a laptop?
I mean, to me, it seems simple these days, but I appreciate it's not a simple thing. Um, this is a brilliant use case of machine learning, right? Because what
Right.
we've done is we called ourselves Measurable. Unbelievably, we measure energy at very high frequency, and the reason we measure in such high frequency, which no one else does, is we can use that data to essentially build a very unique signature of whatever's plugged in, and
Right.
that signature, sort of literally, it can be a squiggly line if you wanted to visualize it, can tell you what kind of device it is. And the brilliance of machine learning is we can feed it a few of these signatures, and over time, it will then start realizing some unique aspects of this. And then it will be able to sort of run by itself and say, hey, that looks like a monitor I've seen, but it may be a different brand. So I'm going to sort of say that's probably a monitor, that's probably a heater. if you plugged in something that no one had ever seen before, and maybe you'd
Yeah,
made
yeah.
it yourself, then obviously we're not gonna be able to get
What have
that.
you plugged in? It says.
Yeah, yeah,
But
remove.
but so it's like, obviously I'm a bit dense, so I'd like to make it simple. Is it like a fingerprint? So devices can have a fingerprint, and your plug is smart enough to know what that is.
It is like a fingerprint, yeah. I guess the difference with this one is we can also realize what the device is doing. So if you plug
Ah,
in your monitor,
yeah,
we can say that's a monitor, but we can also say if it's on or off, or maybe we can even spot if there's something wrong with it. Maybe it's becoming weirdly less efficient over time, and all of
wow.
these aspects we can pick up. Yeah.
So this must have taken quite a long time to program this thing. Did you just spend like Edison doing like the light bulb? You're just doing endless plug it in. What does it look like? How did you teach it?
Quite, it's not far off of that, to be honest with you. So I mean, this is actually the brainchild of Josh, who's my co-founder. He's the
Right,
CTO. He has a special, his PhD was in machine learning, so he was able to. He's one of those people that actually understands how machine learning works.
right,
So rather than kind of give you the detail of it, he'd be the person to ask. But the basics are, yes, we feed it data. That's why it's called machine learning, right? You have to give it data.
right.
You have to train it actually. Um, and if you train this machine learning model that we've created, it can then give you answers back when you question it. What is that? Does it look like something we've seen before? I mean, that's the mysteries of machine learning and neural
So,
networks.
so okay, look, I mean, an office is fairly simple, right? You can have a photocopier, a kettle, obvious things we know, maybe a dishwasher, that sort of stuff.
Mm.
But what about in factories, right, where there's lots of weird equipment, manufacturing plants? Can your plug work there?
It can, yeah. I mean, again, it's depends what it is. If you kind of go down to the basics of what we use anywhere, they can be kind of drilled down to some very basic equipment, like heating equipment is
Yeah.
quite common. Cool, heating and cooling, we can say. Motors are a very common thing,
Okay.
especially in
Yeah.
industry.
Yeah.
And then you get like technology, monitors, laptops, computers, and that's the thing. And if you start thinking about more things, it's really hard to sort of say there are lots of different types of devices. So actually, our model works in a tree sort of format. So if it's something we don't really understand, we can usually guess whether it's a heater, a cooler, or if it might be a big industrial piece of equipment,
Right.
or it might be a piece of user technology. So that's our sort of starting point. So yeah,
Yeah.
if we go into industry, we can look at big things as well. Big things are a little bit different. We don't often recommend controlling the power of big things. You can actually really damage things if they're big enough. So we actually take a slightly different, nuanced approach with big things, but it's the same approach. We measure it, we understand what's going on, we can pick up things, and we can control it in slightly different ways.
I started by talking about the big ticket stuff and the balance with efficiency. Uh, with the idea of what is there a name for this smart plug?
The measurable energy smart plug.
It'll be sponsored soon.
We call it, I mean, we've got an engineer's name for it. That's
I
why I
mean,
thought
the
after that.
LC 170. Call it C3PO, something like that. That'd be really cool.
I mean, it's literally called DG2, so there you go.
DD2. Okay, fine. It's like R2D2. I'll take that.
Yeah.
But the plug, once you've fitted it, so I assume there's a cost, right, to retrofit. So I've got to go. So if you came to my office, you'd have to go to my office, take out the plug points that are there and put them in. So a couple of questions. One, is this stuff expensive? Two, do you need a special person to install it? Because that's a thing that will put businesses off.
Mm.
Three, does it take if it's all this kind of gubbins, do I have to have a program that I have to learn to use it? So can you go through those three quick points?
Yeah. So the first point is I started this with Josh to make sure that anything we created would have a return on investment, right? There is no sustainable technology really that should be made that doesn't have a decent payback on investment. So
Yeah,
that was always the key thing. We have to make this tech give a return. So the good news is we were able to do that. That's why it's taken quite a long time to engineer what a lot of people will think is just a thing that exists, but actually what we've done quite differently is make it in itself is very efficient at running. So Each one of these, for example, these DG2 sockets is just £26, and that's actually quite cheap for a
Yeah,
for a kind of a smart socket or a premium socket. So you buy the hardware, and then we have a sort of software subscription on top.
right.
It's usually sort of annual subscription for what we do, and that again is quite cheap for what it does. So for the whole service that we offer, the machine learning, the dashboard you can log into, all of the energy reporting, that's a roughly £20 per year per
Blimey,
socket.
wow. Yeah, yeah, yeah.
Yeah. So it's very cheap. Most of our customers get a payback in about a year, year and a half is tops. We always try and aim it to be less than 2 years in total for return on investment.
And what
Um,
about fitting it? Do you need some special one of your team to do it?
no, that's again one of the key facets of our design of this product was that it should just be put in. You shouldn't have to do anything.
So any electrician can do it.
Any electric, so it's literally designed. These turn up in a box. I mean, as you can see, they have to actually be the same. There's a British standard around the
Yeah,
design, so
yeah,
we
yeah.
can't mess around with that. They get, the old, if it's a retrofit, the old ones come out, the new ones come in. If
Huh,
it's this type of version, it actually just plugs directly in or connects in. It's designed that it turns up to a building pre-connected to the wireless network that we use as well, so you don't actually have to set up any of this stuff. It's actually plug and play literally, because a lot of people say it's plug and play and it's not actually, but it literally goes in. The one thing people have to do is sort of geolocate the socket within their building. We have a building management system dashboard. They log in. We have a little app. You can say this power socket is on Dan's desk, that
right.
power socket's on Josh's desk, etc. That's the extent of the setup, and
Yeah.
then you can leave it to its thing, and it starts learning, starts then suggesting things to turn off and on, and then it
So
can automatically
let's
do it.
go on to that. So I get the concept, right? It's smart. It knows the difference between what I'm using. So how will it give me my return? So will it say, actually, do you know what? Sumit, your desk, you're not using this plug point at all. So why is it on? Will it turn it off? Will it say you're only using it from this hour to this hour, so I'll only power it? That's the sort of stuff I'm trying to understand because um, there are building management systems, as you said, that will say we can tell how many people have got laptops on, or there's a pool. But the specifics of knowing how to control it, how do I get my money back when I've invested in your gear?
Yeah, so the base service we offer is to automatically turn off things when they are wasting energy. So our definition of wasted energy is broader than just things that aren't being used or in standby, which is what most people will identify. So the very first step for us is knowing the sort of use hours of a building. Most offices, let's say, are inhabited between Monday and Friday, between 6 a.m. and 8 p.m. if you're a good worker. And outside of those hours is our first sort of target area. So that's what the
Right.
system starts with.
Yeah.
It's quite a conservative system. It doesn't kind of sit there waiting for you to leave your desk and then immediately turn everything off. It kind of we don't want to annoy people with our
Yeah,
tech. We
that's what I
want
was going to say. So it's like those lights that turn off as swimming. Remember, you're sitting still and it just goes off and drives you nuts.
Exactly. So we don't want that to happen. So we're quite conservative. If people are in and doing their work, we have a context as well. So if there is a bank of desks that are all being used,
Yeah.
know generally that this building is being used. So that immediately informs the entire system of what kind of going on. But if it's like a Saturday or a Sunday, it's
Yeah.
really obvious because there's nothing going on. So why is the meeting room TV on? Why is the coffee machine on? Why is all the heating, electric heating, all of a sudden turned on? So it's that kind of thing that we start picking up, which is actually the bulk of where we can make quite big savings. Um,
The other question, which I should know this, having been in this industry for 15 years. I don't think I actually know. So my plug point, right? Uh, if my plug point is on, is it actually on, pulling any power? And so do I have to switch it off at the point or not?
no, if there's nothing plugged in, it won't be, there's no power being used.
So you don't actually turn off a plug point, i.e., stop it drawing power.
We do, if there's something plugged in, we will cut power
Ah,
the effect of, flicking a switch on your own power socket. Yeah,
so that's what you'd do. You'd be able to sort of imagine an invisible hand turning off the switch. That's what your machine does.
exactly. Yeah.
What about in terms of the patterns? You talk about that. I think one thing that would make me concerned is hang on a second, this is all data, and people are very aware of their data.
Mm-hmm.
How secure is that? And also, I wouldn't want you knowing that what my business is doing or where people are, because you can work things out, can't you? People can work it out. So,
Mm-hmm.
what do you do about that to reassure clients?
Yeah, I mean it's our primary issue, quite honestly. For me and Josh, especially being technologists, we've always wanted to make sure that it is as secure as it
Yeah,
possibly can be, right? So no system on Earth is 100%
no,
secure. So that's our starting point. So we're always kind of pushing towards it. So the very first thing we did was in-house everything we do. So we actually make our own hardware. These power
wow,
sockets are actually made in Scotland,
brilliant.
using our own sort of tooling and factory line. We even make our own what's called firmware, which is sort of the software that sits inside every power socket. That's a very unusual approach to take.
That's
Normally
very
rely on.
secure because because if you make it somewhere else, it can be hacked. Someone can write the code, all of that.
Exactly. I mean, lots of people have heard of backdoor access and all of
Yeah,
that sort of stuff, from governments and whatnot. So that is cut out of this. So this is all our own stuff. So that's the first starting point. What that means is we can get a lot of security certifications. We have one called Cyber Essentials, for example, which is a UK government mandated certification, and it's actually quite simple for us to get those because we have built in this security by default. And then in terms of customer data, so
yeah.
it is true we can, our sockets are picking up what's going on with the device
I was
all
going to
the
say,
time.
yeah,
So
yeah.
we are picking up, and that's actually useful to identify the wasted energy. So our starting point is we don't really care who's using it. We don't really care even any of the geographical location data or if it's a desk or not. We just care about what's plugged in and what it's doing. So that's our system. It actually immediately anonymizes the data for our machine learning. So we don't take in, like Dan's desk is doing this. We just take in this socket has got this plugged in. We don't know where it is, and our machine learning works on that data.
Gotcha.
It
Yeah, yeah.
then spits out a very binary answer, which is like, does it need to be on or does it need to be off? And that's the extent of our processing of data. And of course, the customer has access to their data as well. So we're not manipulating it in any way, and there's none of that going on. They have full access to everything that we
Yeah,
have.
I suppose the cynical side of me would be like some boss would be able to say, "Oh, hang on, Sumit's computer's not on, not being used as much. He's not working as hard. Spying." I mean, it's tongue in cheek, but these are things that people worry about. The more we have automation, you're starting to get into people's liberties. Is it something you've thought about?
It is, yeah. I mean, there is no simple answer to that.
Yeah,
You can get that from anything, such as an occupancy system for lighting. You
of
can
course.
tell,
Yeah,
is there someone in the office? Are they doing anything? So there are lots of ways, quite honestly, to do that. That's not unique to our system. It's up to the customer, right, to use the technology in the way they want to use it.
yeah.
The essentials of our system are all about spotting wasted energy and controlling wasted energy. So we don't have reports about
Right.
what this desk is doing or anything
Yeah.
like that.
Mr. Bose has not been at his desk for 3 hours.
Exactly.
Um, how do the savings happen? Do they happen simply as that? It switches off, and that's where So for me, as the business, if I've employed you, there isn't anything kind of major. I just see my bill goes down. Simple as that.
Pretty much, yeah. It's quite simple. An effect of our system, it turns things off, or it doesn't, and that's it. So what we actually have this dashboard. It's equivalent to a building management system. You log in, you can see a real-time live tracker of what we've done, as in the system has done to your installation of power sockets. So it can tell you what we've turned off, what we've left on, and actually what difference that's made in terms of energy cost, and greenhouse gas emissions.
I suppose before we go, a couple of things come to mind. Do you need to know from the client, look, never turn this machine off? for example, a life support or a scanner in a hospital has got to have power all the time? Or is your system smart enough to do that? Or do you have to sort of work with the client to say, tell us what must never be off?
Yeah, it's a good question. The first thing we do with customers is always ask them what they want to do with our system. So if it's purely just energy savings, the point here being that some customers don't just want energy savings, they might want monitoring or
Yeah,
safety services.
yeah.
So if they just want energy savings, we'll go in and we'll actually help them either with our online return on investment calculator that you can run yourself, or we can perform a sort of site survey with the customer. We'll literally walk around and suggest, this desk with nothing on it, you're not going to make an energy saving from nothing. But this kitchenette with a coffee machine and this meeting room with lots of AV equipment, this is where you're going to make lots of energy savings. And then we leave it up to the customer, right? Maybe they want to monitor everything, maybe they want to just get some energy savings. And of course, it can be a staged approach as well. Try it on a few desks, put it in your meeting rooms and see how it goes, and then expand the system once you become confident that it does it, which is quite common. So yeah, it's a very honest led approach. We don't want to just chuck loads of sockets out. That won't give you a payback if that's all you want.
So you would go and say, actually, no point changing those sockets. Change the ones there. Yeah, in a different room.
Exactly.
That's the other thing I would think. God, I've got to spend. Even though they're 20 quid, it's quite a lot of money if I've got 200-300 sockets in my place.
It is, yeah. I mean, the classic one is the cleaner socket, which
Yeah, yeah,
yeah,
exactly.
you
Never
don't
mess
really
with the
want that.
cleaner socket.
Yeah, exactly. But there are so many use cases to the system, not just energy saving. It can be all sorts of things that people want from it.
You've been running how long
We've been running for 7 years now.
with this technology now?
Yeah. So I mean, it started from nothing in 2018. Josh and
Yeah.
I started that together. Spent sort of 3 years in a very, it was just me and him. It was COVID time, so we had some fun over that summer of just messing around with technology and making it work.
But I mean, in anger with customers, how long has it been used?
Commercially, we've been launched for 2 years now.
So from that data, can you, and I know it varies obviously depending on but is there a rough average of how much you think your your system would save on a plug, roughly? So
Yeah.
you got to kind of, is it 10% on what normally would be used? Is it more?
So it depends what customer, right? We have three distinct
Okay.
sectors. We have
Yeah,
construction, commercial real estate, and retail and hospitality. They all have quite different use
of
cases.
course.
On average, across all three of them, we look about 25% reduction in the plug load power.
Wow.
If we look at construction site cabins, which is one of our sort of areas that we've grown into, that can be as high as 90-ish% in some cases in the middle of the
Wow.
winter when all the heating is turned on.
Yeah, yeah, yeah.
So yeah, it's quite significant, and we have lots of case studies on our website as well that
And
sort of show.
so you've said about 40% of an average office is the plugs. And of that, you're saving 25% of that, then basically. That's what you're saying.
Yes,
Right.
exactly. Yeah.
Well, the last thing is, I think it's really great that you're doing it all here. A lot of people like you would have probably manufactured abroad. Um, it's one of those things where we're trying to get more British industry. Why have you kept it here? Because that's quite an interesting one. Because I'm sure that the cost matrix would be a lot cheaper in the Far East. Was there a particular decision to build everything here and make your factory here?
Yeah, I mean, actually, we couldn't make it that much cheaper outside of the UK. I think that comes from having Josh, who is a very technical person, yeah, as well as machine learning PhD. He knows how to do robotics as well. So he kind of knows how to build stuff. And if you can approach it like that, you can literally set up your own manufacturing line and determine how much it costs. And that's exactly what we've done. And that's why we've stayed in the UK because we were able to keep costs really small. Um, the other side of that is the cybersecurity aspect.
Of course.
It's very good to have it here because, as you know, there are very well-known examples in the world of devices being intercepted en route to places, being up, their software being changed, etc. So it's really good for us to have it here. It's also great for quality control because although Scotland isn't that, it's quite far away from us, but it's easy to get there compared to some other places. So it's actually quite cost effective. We're going to try and keep it as local as we can. Obviously, it's great for sustainability.
Yes, I was going to
So
say.
we're also thinking of internationalization of the company as well, and we're trying to do these local supply chains wherever we can get to.
And finally, how has it helped you? I assume your house is all the plug points behind you are all yours, are they?
They are, yeah. I mean, you can see behind me some of the older versions that we've had installed. But
So
yeah, no,
have you saved yourself then?
yeah. I mean, I think it's brilliant. Most people in their house have a little smart meter, right, that
Yeah, yeah,
tells
I've
you.
got one of those. Yeah,
Yeah, and usually most people get to about 200, 250 watts, and they're kind of
right.
like, oh my God, I don't know what's plugged in. Help
Yeah,
me. But I'm very proud to say that I know exactly what's going on now, and
yeah.
I can turn it all off.
Listen, I think what you've come up with is flipping clever. Your business partner clearly a sort of, man who's sitting behind the code in the Matrix. Sounds like that. Best of luck with what you're doing at Measurable. Really, really, thanks for your time, Dan.
Thank you very much. Cheers.